Hello everyone. After completing that practice set 1.1, now we will switch to another new topic, that is comparison of rational numbers. So let us see the topic, comparison of rational numbers. Now let us study what will be there in comparison now. As we already studied that comparison means what? We have to consider the numbers, a pair of numbers, and within that two numbers, if suppose 5 and 6 will be there, by that time what we will consider comparison of these two numbers, like 5 will be there, so value of that 5 will be greater or value of that 6 will be greater. By that time value of 6 will be greater, and by that time we will show it by this symbol. Okay, randomly I have placed it, but I hope you understood what I would like to tell you. Okay, so here in the case of rational numbers, the comparison we have to do that. Don't get confused. Like the real numbers, we can compare the rational numbers too. Okay, let us see how to compare that two rational numbers. Like the natural numbers, we cannot compare that, because in natural numbers, like suppose here is 5 and 6. Okay, 5 as well as 6 here, so we can compare them like by looking at their values. So 5 will be greater or 6 will be greater. Here in this case 6 will be the greater number, so we can write like this. Okay, but in case of these rational numbers, we have to check the numerator as well as the denominator of this rational number. Okay, now in this case we will write here, suppose that first number. Here after multiplying this 5 upon 4 by 5 in numerator by 5 in denominator, we will get another fraction, that will be another rational number, that will be 5 multiplied by 5 25, and 4 multiplied by 5 20. It means 25 upon 20 will be our another. So like this we will get that new rational number, that is 25 upon 20. So like this we can multiply any number in numerator, the same number should be multiplied at denominator. By this way we will get an equivalent fraction. It means our original fraction will be what? 5 upon 4, and what will be this 25 upon 20? That will be same as 5 upon 4. We can consider it. So now for for comparison purpose of this rational numbers, we have to consider the denominators over here. First of all, the first method is what? We have to consider their denominators. What is here? 4, and here 3 is there. So if we will go for their LCM of denominator, by that time we will get a common number which can be the multiple of 4 as well as 3. Okay, and that time students, so now dear students, we need to do denominator as 12 here like this. So we need to multiply this 4 by 3. The same thing we will do in numerator now. We will multiply this 5 by 3. And like this way, we will get in numerator 5 multiplied by 3, 15 exactly. And in denominator what we will get? That will be 12 as per our requirement. Because what we need here, the denominator should be for both rational number should be same, and that same it means that should be that is that is that is LCM of 4 and 3 is 12. Therefore that will be 12 here like this. Let me minimize. Okay, let me enlarge that like this way. Okay, so see now the same thing we will do with that another rational number. Okay, see now, let me do that. Okay, so see now, our another rational number was 2 upon 3. So now we can multiply this 3 by 4. Why? Because we need 12 as a denominator over here. So first of all we will consider about denominator, and 3 multiplied by 4 we have done in denominator. That's why we have to do the same procedure in numerator also. So we have to multiply by 4 with this 2, and now like this way we will get in denominator 12. So what will be in numerator now? 2 multiplied by 4, and 2 multiplied by 4 will be how much? That will be your 8. So 8 will be in numerator and 12 will be in denominator. Now it is very easy for us to compare these new fractions, these new rational numbers here. The first one is what? The first one is 15 divided by 12, and that another one is what? Let me do it. That another one is 8 divided by 12. And now here, what is common here? In these fractions, the common thing is that denominator are same for both the fractions. In case if denominators are same, by that time we will think about only numerators. And in this case here, which one is having higher value, the highest number in numerator, that will be the greater rational number. This is the simplest trick. So in this case, this 15 upon 12 will be the greater fraction. It means that will be the greater rational number. So like this way we can compare it. Okay, now we will compare the two rational numbers, but the condition is that one rational number will be the negative rational number and another one will be the positive rational number. Let me write down here. These are the two rational numbers. Here one is positive rational number and another one is negative rational number. So this minus 7 upon 9, this is negative rational number, and this 4 upon 5 will be another positive rational numbers. So use your common sense here and think about it and decide, that is negative rational numbers are always less than that of positive rational numbers. So do we need to compare here, or directly we can write? Yes, directly we can write that whenever one positive rational number and one negative rational number are getting compared, by the time you need not to do any calculation but apply your common sense, and by that time you can declare directly the positive number will be always greater than the negative numbers. So in this case also, even though they are the rational numbers, but still we can do the same procedure here. We can declare the positive rational number greater than that of negative rational numbers. So we can write here like this. We can write here, let me write, we can directly write it as this minus 7 upon 9 is less than 4 upon 5, because 4 upon 5, this fraction, this rational number, it is positive number. Okay, and this minus 7 upon 9 is negative number. So we can write here that negative rational number is always less than positive rational number. Okay, so this will be your answer for this condition. Now let's come to another example now. Okay, let me do it. Okay, see now this another example. In this example, both the rational numbers are negative. Here minus 7 upon 3 and here minus 5 upon, let me take it properly. Okay, see, that is minus 4 upon 5. Earlier it was minus 5 upon 5, but means whatever number it will be in numerator and denominator, so we need not to write it like that. That will be directly 1. Okay, so now we have taken that minus 4 upon 5. Here there is another one minus 7 upon 3. Now we need to compare this one now, and in this case both the rational numbers are negative rational numbers. Now let's study about it. See, in this case we need to compare both the rational numbers, and we need to treat both the rational numbers first as positive rational numbers. It means this minus 3 upon 7 can be treated as plus. Okay, so it will become plus 7 upon 3. Okay, and that another one, that will be this another rational numbers that we will consider here, that is minus 4 upon 5. We have to treat this again as a positive rational number. Okay, let me do it. So like this way we can consider both the rational numbers as positive rational numbers, and by this way now we can take the denominators. Now consider both the denominators, that are 3 and 5. If we will compare them, by the time you will see that both are different. Okay, so by this time we need to take again LCM of both the denominators, and now we will get equivalent fractions of both. We have to take equivalent fractions of both, and that can be possible by multiplying numerator and denominator by same number. Now think about both the numbers first. What would be the LCM for 3 and 5? LCM means what? Such a number which can be multiple of both 3 as well as 5. Yes, of course, that could be 15. Okay, so now that 15 will be our LCM for, that could be LCM for 3 as well as 5. Okay, this 15 would be LCM for 3 as well as 5. Now let me do that equivalent fractions here. It will be like, okay, see, it will be like this: 7 upon 3 multiplied by something, and we need denominator as 15 here. Okay, exactly the same scene here in another rational number, that is 4 upon 5 it will be, and here in denominator we need 15. In both the cases we need 15. For that we have to multiply the fractions, denominator of that fractions, by any number so that we can get 15. But here we can get 15 only when we will multiply this 3 by 5, and the same thing we have to repeat for numerator. So 7 multiplied by 5 it should be, and by this way we will get 7 multiplied by 5 will be how much? 35. So that 35 will be here in the numerator here, so it will be here 35. The same scene here in another case, that is 4 upon 5 it is. So the denominator, that will be 5, that should get multiplied by such a number so that we could get 15 over here. So we have to multiply this 5 by 3. The same thing we have to repeat for numerator, that is 4 multiplied by 3, and like this way we will get 4 multiplied by 3 will be 12. So that 12 will be in numerator and 15 will be in denominator. So in this way we will get 15 15 in the denominator, both the denominators. See here, 15 here, 15 here. Okay, but now we can compare the numerators. The numerators are 35 and 12. So now by this time we have to write here, let me write like this, that will be 12 upon 15 for that second fraction, that second rational number, and for first rational number that will be 35 upon 15. Now easily you can compare it by looking at the numerators, which one will be having greater numerator, that will be the greater number. So like this way we can say that 35 upon 15 will be the greater rational number. But in this case both the rational numbers are having negative sign. It means this will be reverse for negative sign. Indirectly I would like to tell you that, see, in this case we have considered both the rational numbers as positive, and by this way we have reached up to the comparison, and now we have come to the conclusion that 35 upon 15, it means it is equivalent to positive 7 upon 3. Okay, and that is greater than this 12 upon 15 means positive 5 upon 4. But what we have given, we have given minus 4 upon 5 and minus 7 upon 3. So this sign will be reverse for negative rational numbers. So directly we can reach up to the final conclusion, that is, let me write it now. Okay, like this it will be. It means minus 35 upon 15 is less than minus 12 upon 15. As we already have seen there on number line, whatever that negative numbers are there, if their values are getting increasing again and again, like minus 1, that is greater than minus 2, minus 3 is less than minus 2, minus 4 is less than minus 3, like that numbers are increasing in negative direction, their value will be getting minimized there. Okay, their value will be low as we are going to increase their numbers. So the same scenario here, and finally we have concluded up to the conclusion that minus 7 upon 3 is less than minus 4 upon 5. So we can write it as like this. So we can write this comparison of negative rational numbers as like this. Okay. Okay. Apart from these examples, there are few rules have been given in your syllabus for comparison of rational numbers. Let us discuss that rules now. Let me open it in your textbook that are already given in your textbook. Let me show it to you. Okay, here are the rules in your textbook. In these rules, it had given here if a upon b and c upon d are the rational numbers. Rational number means we have already discussed about it. Rational number means the number which is given in the form of numerator and denominator. That will be a simply rational number. It could be positive rational number or it could be negative rational number. But here the conditions are if a upon b and c upon d are the rational numbers such that b and d are positive. It means your denominator should be positive, both the denominators b and d as well. Okay, if both are positive, by the time these rules are applicable. Let us discuss that first rule first. Okay, in the first rule it had mentioned here, that is if a into d is greater than b into c, that time, see now, the cross connection is here, a into d, and another one is what, that b into c. Okay, this b into c. So if we are going for this cross connection, by that time this multiplication, if left side multiplication is greater than that of right side multiplication, that time whichever will be the direction greater, that side rational number will be greater. See, in this case this a into d is smaller than that of b into c. That time b into c is greater means right hand side is greater. That's why right side, this fraction, this rational number has mentioned as greater rational number. See here, this a upon b and this c upon d both are there, but just because that right hand side is greater than that of left hand side, that's why this c upon d, these rational numbers are declared as a greater rational number here. This is your first rule. Like the same second rule, let us see here the second rule again. In that each and every case, if you have seen here, then you have to do the cross multiplication, like a multiplied by d and another one is this b multiplied by c. Okay, this cross multiplication we have to follow every time. And here a into d in first case is less than that of b into c. That's why b into c means right hand side is greater. That's why we will declare c upon d is greater. In this case again, the same multiplication we have to do, the cross multiplication. Okay, if both are equal, that time both rational numbers will be equal. In the third case, again cross multiplication, a into d is greater than b into c. That time if left hand side is greater, that time your left hand side rational number will be greater. These are the simplest rule, simplest tricks also. Okay, now let's discuss about practice set 1.2 in your next video lecture. Till then, practice few examples from your textbook also, and consider by your own too, and just create your own ideas there. Okay, we will discuss about 1.2, practice at 1.2 in next video lecture. Okay, my dear students, now these are the homework questions that I am giving to you. So those who are honestly watching these videos and studying sincerely, they have to respond for these answers. Okay, even though if you are not solving, but still you can reply in that comment box just below these videos. You can write there for question number 1 which one is greater, for question number 2 which one is greater, like this you can reply here. Okay, let me show it to you. Okay, see dear students, here as in your maths class you can see the videos like this. Okay, wherever these videos had been uploaded, just below that here add a class comment. Here at that place you can answer for your homework questions. Okay, even though you are not solving in notebooks, doesn't matter, but at least let me know that you are watching these videos and you are understanding. If any doubt or any query, you can post it, you can ask me here also. Okay, but my sincere request to you all is that just avoid WhatsApp replies, because WhatsApp means what, it will occupy your phone memory, and this is the solution for solving your mobile memories. Okay, that's why we are using this Google Classroom, and this is very effective. So let's interact with it, use it, and then apply it. Okay, so let me upload that videos for you people, and after watching that videos you have to reply me for answers of your homework questions here in this comment box. Okay, I'm waiting for your replies. Okay guys, take care.